Alright. Hello, this is Mac O'Leary, and this is Physics 2211, Lab Report number 2. So the purpose of this lab was to gain insights into the two-dimensional kinematics of objects, so projectile motion, with and without drag. So gravity is always considered, but drag is the special case here. So in order to complete this lab, we used rulers, 3 of them, 1, 2, and 3, and a paper ball. That was our projectile. And then we also used a cell phone camera, the tracker app, and GlowScript Python. In the end, we had slight error with our video because the way it decided to record, the ball was essentially bouncing back and forth. It would be here and then back to here. So that didn't give us the best data, but in the end, we were able to confirm the principles of projectile motion and show that the kinematic equations applied. Methodology. So the central idea for this lab was to measure and track an object moving in 2 dimensions in projectile motion. We initially assumed there's no drag, but we also did calculate that later. So that was done through the B constant, which was a coefficient that would be plugged into the drag equation. This is because the no drag assumption is reasonable because the object was not moving very fast, so that was a safe assumption. However, we did factor in drag in order to contribute to the realism. The system in this instance was the ball, and the surroundings were the earth and the air, and which both exerted forces on the ball at some point. So for this experiment, we used the tracker app. So as you can see, I don't know if I have, do I have it? Yeah. So we would throw the ball from here, and then we would input all the tracks, and then that was used to collect the data, which was here, and then from there we exported it to a Google spreadsheet, which was used to create the graphs and show us trends in the data. That's not going to work. The coding for this lab was done in GlowScript Python. So we used a traditional velocity position update formula, and we factored in gravity, and drag. So the B constant that was shown above, in this instance it was 0 initially when we were for no drag, so that would mean that there was no force of drag. Gravity was always the mass of the ball times gravity, and then update the velocity, update the position, and then I had the print statement just for debugging, and that's still in there. Continuing on, and then you get everything down there. From the spreadsheet, we got an initial velocity and position of 2.25 and 3.65 meters per second, and that's about reasonable. We also used the coding to create graphs for all of our relevant forces. Next up, data analysis. So this is our measured data up here. In the first half of the data, you can see the inconsistency that I mentioned in our data collection, and you can also see that in the velocity position, which was really just one data point minus the position of the next divided by the change in time. So you see a pretty weird trend in both the X and the Y. Once you get past that halfway point, the data gets really consistent, and that's what was used to find initial velocities and positions. The Y data looks very good. You can compare that with what we get from all the other So this is the with drag case up here in the top right, and then no drag down in the bottom left. Next up. So what does it mean? The terminal velocity, which was not reached in this experiment, is the velocity where there's no net force on the object, so that is when the force of drag is equal to the force of gravity, implying that the object is falling straight down. It was not reached in this experiment because the object was not moving fast enough. If an object were thrown straight upwards versus at an angle, you break it down into components and then apply kinematic equations. You would only solve for the y component in both cases, and the time in the air does not change. Conclusion. This experiment sought to measure the trajectory of an object moving at projectile motion. It was expected that the object would be subject just to the forces of gravity and drag, which would then be calculated and quantified. And the measured results showed pretty good accordance with the calculated ones. There was a slight error due to the technology used, but other than that, everything looked pretty good. Thank you.